One of my favorite subjects to follow is astronomy. Day after day, I find out about a new phenomenon, mission, or discovery that changes my understanding of what astronomy is. A few days ago, I was scrolling through the homepage of one of my favorite websites, Futurism.com, and found an article written by Victor Tengerman on July 15, 2019, titled, NASA Organizes Huge Effort to Study Alien Life in Titan's Ocean. There could be the building blocks of life on Titan, Saturn's largest moon, and NASA wants to find out if they are there or not. This is amazing, but of all the celestial bodies in our solar system, why is this moon so special? To try and understand why this moon, Titan, is so important, we should start with the fundamentals, our solar system. We were all taught the basics of our solar system. First comes the Sun, then Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. There's an asteroid belt between Mars and Jupiter. And then there's the moons. We only have one, but there are over 150 other confirmed moons in our solar system. And of course, the dwarf planets like Pluto. Obviously, the fan favorite is Earth, because we live here. But recently, astronomers and astrophysicists have been taking a closer look at Saturn, the planet that NASA calls the jewel of our solar system. Saturn is the second largest and the sixth farthest planet from the Sun, but it is known for its beautiful rings. Saturn isn't the only planet to have rings, but Saturn's thousands of icy rings are singular in their beauty and complexity. Inside of those rings, you'll find a just as spectacular planet, which is classified as a gas giant and is made mostly out of hydrogen and helium, according to the NASA website. Saturn has 62 moons, 2 of which are considered critical science targets by NASA. NASA theorizes that Titan Enceladus is the most reflective body in our solar system. It is an icy moon with liquid oceans beneath a frozen exterior, which spray through cracks on the surface. NASA says that Enceladus has most of the chemical ingredients needed for life, and likely has hydrothermal vents spewing out hot, mineral-rich water into its ocean. It is the 6th largest moon of Saturn, but it is only about the width of Arizona. Titan is a little larger than Mercury, and the only moon in our solar system with a significant atmosphere, which is made up of mostly nitrogen and looks a lot like Earth's atmosphere a long time ago. Other than Earth, Titan is the only other place in our solar system where you can find bodies of liquid like oceans, rivers, and lakes on its surface. Unlike Earth, though, these liquid bodies are made up of liquid hydrocarbons like methane and ethane, but underneath this layer of liquid methane systems and ice, there is a vast ocean made of water. NASA theorizes that Titan's subsurface water could be a place to harbor life as we know it, while its surface lakes and seas of liquid hydrocarbons could conceivably harbor life that uses different chemistry than we're used to, that is, life as we don't know it. Titan could also be a lifeless world. Following in the footsteps of the great Carl Sagan, who said, "Even if the aliens are short, dour, and sexually obsessed, if they're here, I want to know about them." Today, scientists also want to know. Now, I can't mention Saturn or Titan without mentioning the Cassini mission, which NASA called one of its most ambitious efforts ever mounted in planetary exploration. Cassini, backed by the combined efforts of NASA, ESA, the European Space Agency, and ASI, the Italian Space Agency, Cassini was launched on October 15, 1997 from Cape Canaveral, Florida. It traveled 890 million miles and reached Saturn 7 years later, in July 2004. It was on a mission to study Saturn, its rings, and its satellites. Specifically, though, Titan. Cassini transported a special ESA-built probe called Huygens, which was specifically designed to land on Titan. And it did successfully on January 14, 2005, according to the ESA website. According to NASA, this landing was the farthest from Earth and the first in the outer solar system in history. This probe discovered much about Titan's surface, like the descriptors I used before. On the surface, Huygens found, according to the ESA, liquid methane, sand made up of ice, water, and pebbles, carbon dioxide, and weather conditions like winds, rain, a temperature of negative 170 degrees Celsius, and an atmospheric pressure slightly higher than Earth's. In Titan's atmosphere, Huygens found a strong polar wind, a presence of aerosols or dust particles, and found that complex organic compounds, or the building blocks of the amino acids necessary for life, were present in both gas and solid phases. Other than the success of Huygens and its findings on Titan, Cassini was a very successful mission. It discovered many novel things about Saturn, its moons, and its rings, and I used to describe Enceladus earlier. The dynamic nature of Saturn's rings and how they are a laboratory for how planets or moons form. Captured the first complete view of the hexagon-shaped jet stream that surrounds Saturn's North Pole, and discovered a giant hurricane-like vortex at both of the planet's poles. The mass amount of information that Cassini and Huygens sent back to Earth will take decades to fully unpack, but scientific curiosity is a force of its own kind and difficult to stop. The most remarkable discovery in all of astronomy is that the stars are made of atoms of the same kind as those on the Earth. This was said by Richard P. Feynman once, and that is exactly what Cassini delivered. It's been 15 years since Huygens landed on Titan. Now NASA and the scientific community have more questions they want answered. So excited and curious, they started planning a new mission to Titan, and they named it Dragonfly. Dragonfly's mission is to advance their search for the building blocks of life. But the mission's 4 main objectives are, according to Victor Tangerman's article on futurism, are: first, the team wants to understand how molecules are transported from the surface of Titan to its oceans. Second, they want to find out if complex organisms are even capable to survive in Titan's vast subsurface oceans. Third, depending on how the first two objectives go, the next step is to explore how much chemical energy is available to life for metabolizing. Finally, the team wants to find a way to detect biosignatures that remain in the ocean, particularly a tricky task given that Titan's oceans are covered by an outer shell and an organic-rich atmosphere. Dragonfly is scheduled to launch in 2026 and is estimated to arrive at Titan in 2034. Victor Tangerman, in his Futurism article, wrote, "If all goes according to plan, NASA's Dragonfly rotorcraft will touch down on the distant ocean world 15 years from now. By then, we will likely have a much better understanding of what awaits the spacecraft there."
As Sir Isaac Newton so eloquently stated, "If I have seen farther than others, it is by standing upon the shoulders of giants." Science builds on itself. Therefore, the Dragonfly mission would not have been possible without Cassini. It gave us a closer look at Saturn, pushed the limits of human ingenuity, and showed us that there is a possibility for life outside of this planet. Following Cassini's wake, once again, NASA will once again do what no one else can do with the Dragonfly mission, said NASA Administrator Jim Bridenstine. The cutting-edge mission would have been unthinkable even just a few years ago, but now we're ready for Dragonfly's amazing flight. When asked the question, "Does extraterrestrial life exist?" Stephen Hawking responded, "There is no bigger question. It is time to commit to finding the answer, to search for life beyond Earth. This is precisely what Dragonfly is looking to do. But the chances are still low that anything will be found. However, Einstein once said, 'Why should Earth be the only planet supporting human life?' Titan is unlike any other place in the solar system, and Dragonfly is like no other mission," said Thomas Zurbuchen, NASA's Associate Administrator for Science. When asked the question, "Does extraterrestrial life exist?" Stephen Hawking responded, "There is no bigger question. It is time to commit to finding the answer, to search for life beyond this Earth. This is precisely what Dragonfly is looking to do. But the chances are still low that anything will be found. However, Einstein did once say, why should the Earth be the only planet supporting human life?" Titan is unlike any other place in the solar system, and Dragonfly is like no other mission, said Thomas Zurbuchen, NASA's Associate Administrator for Science at the agency's headquarters in Washington. So if life could form somewhere else in our solar system, wouldn't it be there? And what if they do find the building blocks for life, and maybe even life itself? It would be amazing and awesome. Most importantly, it would give us a better understanding of our solar system, the universe, and the existence of life itself.